Okay, so now we need to talk about reabsorption. And in doing this, we are moving into the proximal convoluted tubule. So this is the PCT over here. So PCT. And we're going to look specifically at this. We're going to make a close-up of that little box right there. So the PCT, basically about 70% of reabsorption occurs here. So that's a lot. Okay, so we're absorbing all kinds of stuff. Sodium ions, potassium ions, hydrogens, water, bicarb. I mean, we're basically in a 24-hour period absorbing about a pound of bicarbonate, amino acids, glucose, all kinds of things. And here's the thing. Right here, that was the renal corpuscle. What's going to happen there? Filtration. Guess what's going to be filtered out? Everything. Everything. Okay? The blood's going in here. Those crazy, fenestrated, leaky capillaries are going to let everything out. Anything that will fit goes into the Bowman's capsule. Okay? So literally anything that fits gets dumped into Bowman's capsule. Okay? So just realize that everything is getting dumped. So if only the things that don't fit, which are going to be blood cells and basically proteins, everybody else is going to get dumped into Bowman's capsule. Okay? So what would happen if that kind of stayed there? If it stayed there and got through the nephron and got peed out? We'd be in a heap of trouble because we can't live without all those solutes that are being pushed into Bowman's capsule. Remember, filtration is general. It's not like the kidneys are going, oh, okay, well, let me pick out, some sodium here. We probably can throw that out, and maybe a little bit of calcium or something like that. No, it just comes out. It's just there. So it's the responsibility of the nephron to pull back in and reabsorb the stuff that we need. So most of that occurs in the proximal convoluted tubule. Okay, so the proximal convoluted tubule, if I make my little cell, I guess I can make it yellow. So if I make my little cell, and the cells in the proximal convoluted tubule, you should know, are going to be cuboidal, right? Simple cuboidal cells are here. Here's my little membrane there. And they do have microvilli. So, they have microvilli because we need to get all, 70% of this stuff reabsorbed. So out here again is the lumen. And of course we need a blood supply here. So we've got blood going on down here. Okay. So we want to reabsorb stuff into the blood. And most things, this isn't filtration. It isn't like it's just coming back in. It kind of has to be helped. So these things are brought in through what we call transporters. And we've seen these guys before. So we're going to use glucose as the example of how the kidney transports stuff back into the blood. And most things work about this way. So if you remember, sodium because it's everywhere and it's coming into the cell, it's an easy solute to use to move things. Okay, so with glucose, so glucose is filtered out. Okay, so how much glucose needs to go back into the body? How much should be in the urine? Well, 0. None should be in the urine. So all glucose is transferred back into the blood. I mean, glucose is like gold, okay? So we have glucose and we have these blue sodium out here. And we're going to, reabsorb some sodium, and that's easy to do because it's going to come into the cell anyway. So we have these little transporters, and we saw them before. So here's my little transporter here. It has a name. It's called Sigled. So sodium glucose transporter, okay? So when sodium comes in, and it comes, glucose comes too, okay? And of course, on the cell, because we must have this crazy thing, we of course have our friend, the sodium-potassium pump, or sodium-potassium ATPase, right? So sodium then will be pumped out into the blood. So that's sodium in here. So there's reabsorption of sodium. And a little green for this. We've got a little potassium coming in because that's what the sodium-potassium pump does. And then down here on the membrane, we have another transporter. And that transporter is called glut. And we've seen that guy before as well. And glut allows glucose across into the blood. Okay. Potassium, well, we know all about potassium. Potassium's got lots of leaky channels for the guy, so it's just going to go right back out. No big deal. Okay. So we're moving this, sodium and glucose through into the blood. Well, guess what follows that? All right. Well, water is going to follow these solutes just through osmosis. So now, awesome, we're getting the reabsorption of sodium, we're getting the reabsorption of glucose, and we're reabsorbing water all from the filtrate. Okay? Water is going to follow these solutes back in. Okay? So a result of that is that the osmolarity of the filtrate is going to change. So the osmolarity of the filtrate is going to change. Okay? So the osmolarity is decreasing. So that means that the filtrate is starting to get more concentrated, okay, within this proximal convoluted tubule. But that's basically how most of these things are gotten from the lumen, from the filtrate, and put back in the blood. 70% of it is reabsorbed here at the proximal convoluted tubule. Okay. So there's something that can occur here that we need to talk about. So in the next video, we'll talk about transport maximum and to finish this subject.